Sound check. Sound check. Is this a good volume?
I'll just keep going and Autumn will set the volume.
Everyone can hear me okay? Welcome to ICMC. Welcome to Boston. All right. Okay, sound check complete. Thank you. See you, everyone, in a few minutes.
All right, and then
Hello, everyone. We're about to start. In a minute, we're going to start. So sit down, relax, and enjoy the show. Good day, everyone. Welcome to ICMC 2025, Curiosity, Play, and Innovation, 50th anniversary. What a mouthful. And I'm very glad to be here to introduce you to the first keynote of the conference. My name is Victor Zappi. I'm a professor here at Northeastern. And here is Anna Huang. So let me read a brief biography. So Anna Huang is an associate professor at MIT with a shared position in music and theater arts and electrical engineering and computer science. Previously, Anna was based in Montreal and held the Canada CFAR AI chair at MILA, the Quebec AI Institute. For the past 10 years, Anna has been with the Magenta team in Google Brain and then Google DeepMind, and spearheading efforts in generative modeling, reinforcement learning, and human-computer interaction. She's the creator of Music Transformer and the machine learning model Coconut that powered the Bach Doodle. You may have tried this. Anna started her research in music and computers as a college student at the University of South California with Elaine Chu's Music Computation and Cognition Lab. She then went to the MIT Media Lab, here around the corner, and was one of Barry Vercoe's last students. During her PhD at Harvard, she spent several years in Harvard's studio for electroacoustic composition, and I'm very glad that we're neighbors right now, from Northeastern to MIT, just a short bike ride. So let's a round of applause again for Anna, and the floor is yours.
Thank you so much, Victor, for the kind introduction. And thank you, Tony, for the invitation and organizing this amazing conference to bring all of us together. This place feels very special to me because ICMC was like the first conference I went to as a student. And it happened to be in Montreal. I think it was 2009. And it was just an amazing experience. As you all know, it feels like a conference and a music festival all in one. And you're really, kind of juggling, like hanging out with everyone. And so it feels really like a full circle to come back here and be able to speak with all of you. And to me, this feels like a beginning for me for a next chapter. So I feel really lucky to have all of your support as we can kind of be thinking about these problems together and moving into a very exciting kind of chapter of exploration. So today I'm going to talk about we're kind of all searching for something, and I work with a lot with kind of machine learning techniques, with AI techniques. So I'm constantly thinking about, how do we find this human-AI resonance? So when I talk to people and they ask me what I do, and a lot of times they make a guess about what I do when I say I work with music and computers and machine learning. And so one time I had a colleague ask me, like, is it that what you do is like you're trying to design like a third robot arm to play piano with you? My sound check clip was piano, and I didn't hear it, but we'll do this. We'll check on sound later. So they're like, is it like a third arm, like robotic arm? So at the time, I didn't really like resonate with this metaphor, but later on, I realized they were actually somebody who works on like prosthetics. So in prosthetics, they're really thinking about the human-machine symbiosis. And in many ways, yeah, like it's not just about building an arm or leg that can support you, but it has to move in motion with you together. It has to understand your intentions. Like even reaching for a cup of water can be really hard if you don't know that's what you're going for. And also like how we walk is a signature of how we carry ourselves, and the machine has to be able to carry us in those ways. So then I realized, yeah, like there's so much kind of big questions behind that metaphor, and also for us, if it's a third arm, then it really changes your balance, like when it's embodied. It changes how you think about coordination. It changes how you think about what kinds of roles are possible in this music-making performance setting. And later on in my talk, I'm going to also talk about examples of, this one feels a little bit like, yeah, like the arm is an extension to yourself, like sometimes instruments are like extensions to ourselves. But what if there is another being that's like another foreshadow, another cat in the ensemble? How does that change the dynamics of the interaction between the musicians and the group? So that's my little prelude for everyone. So for my talk today, it's going to be 2 parts. And first, I'm going to talk about how do we use neural networks to model musical structure, and then go from there to how do we get neural networks to actually think about interaction and also human AI improvisation. So I'll use a couple of work to talk about, first from structure, thinking about long-term structure, to thinking about interaction, how music requires this synchronous interaction that's actually quite unique in our domain, and also thinking about this real-time coordination, also thinking about how to situate this in different kinds of musical traditions, and how we even start thinking about planning. So after this first part, we would have gotten to about the golden mean part of the talk, if time goes well. So the next part, I'll focus on 3 examples that I'm kind of tying together that all think about this kind of rewriting, regeneration through like masking different parts of the material. Some is on symbolic music, some is on audio, and we'll see how composers bring it into their practice, and also some new experiments on thinking about rewriting audio for different stylistic explorations. Okay, yeah. So for Music Transformer, this was one of my early works. So there we were really thinking about, okay, how do we get this kind of structure, recurring structure in music? And Transformers felt very well suited for this because, yeah, it has really good memory, it's really flexible on the kinds of hierarchical structures you can learn. So I felt, yeah, this should work well. And we also wanted to think about performance. Yeah, like so much of what we're hearing in music is the performer communicating and adding all the expressive timing and also dynamics. How do we also capture that? So the data set we worked with was the Yamaha e-piano from the e-piano competition, where a lot of amateur but very, very good pianists played on this clavier. So we were able to record all that performance nuances. So after many months of working, yeah, we finally got it together. And yeah, it was, and I was curious why it was able to, yeah, really pick up on the structure. So we opened up the black box and did some visualization. And this is like a first kind of prototype of it. We're showing the last layer and the different colors of the different heads. So I'll show you an animation of how this sounds and how. So does it sound good? Oh, sorry. I was listening to the sound, and I think on stage it's a little softer. So I was kind of waiting for it to come out. But the sound playback was OK? OK. Maybe a little bit Oh, okay. So I think the control is over there. So this tremolo gesture is like the recurring theme. So every time it comes out, you see it referencing like the earlier instances of it. So in this tradition, a lot of times the performance is this interleaving of composition, improvisation, and composition. So when the musician is in the improvisation setting, they draw on a lot of previous material and they build on it. But at some point, they have to think about, okay, how am I going to return to the composition? How can I, like I have this limited amount of time. How do I prepare for it? And given where I am. So this is called kind of a landing problem. So this is actually different teachers, for example, teach this differently and also practice this differently. And so this particular kind of thinking, Nitya is actually drawing from, okay, so yeah, this is like, we're starting low and then the arrival point, the composition is higher, so we kind of think about this way of like going up and then to land on it. And yeah, depending on where you are, you would do this preparation differently. Yeah, so this is Nitya's drawing from her learnings from her teacher, who is kind of following this tradition from her teacher. So what you're going to hear is Nitya's grand teacher singing these phrases and demonstrating how you might do the landing. So I just wanted to kind of play you two examples of this kind of landing. And what we're interested in is, kind of really thinking about this musically, and thinking about, if you had these, we're kind of thinking about it in the context of reinforcement learning, and thinking about, if you have a goal here and here is where you are, what are the different ways you want to arrive at that point, kind of given this like limited time. And depending on where you are, you would have to kind of like reason about it differently. Oh, okay. So you. So we're in the. Okay, so that was the ending. I think next time you'll be able to hear the composition part. This is another way. So that was leading back to the composition. So we're really interested in thinking about this in some ways as a kind of creative reasoning. So we think about reasoning a lot in language, for example. When you're proving a mathematical theorem, you're trying to kind of figure out what are the intermediate steps, and sometimes you might go down kind of a wrong path, and you see the models like being able to reflect on that, and then kind of like replan. And also with like AlphaGo, thinking about you have to like kind of do these row outs, thinking about the future, and kind of to decide where you're going to go next. So we feel, in this music setting, actually, a lot of that is what musicians are thinking about that and practicing that and doing that on the fly. And it would be really interesting to study that and also design models that kind of take all of that into account. Okay, so that was my first arc for the first part. Thinking about, first from like how do you model musical structure, then to thinking about, what are the particular requirements for interaction, especially in the improvisation setting where you have to think about this real-time coordination, and then thinking about improvisation in a different tradition, what are the new facets that would kind of a different tradition would bring out, and how that brings us to really, really interesting technical challenges. So for the second part, I'm going to bring together 3 pieces of work that maybe on the surface, that are really, really different, but they all use kind of the same technical material to imagine, which is, thinking about different ways, like given some material, how you would rework it in different contexts. So the first one I'm going to talk about is, a little bit of kind of the math behind it. So I say it's the theory. And then I'm going to go into how kind of a practice, meaning like an actual realization of this in a performance, and then talk about an early experiment we're doing. So so Coconut is the model behind the Black Doodle. And at the time when I was designing the model, some things I was thinking about is, I remember, I think maybe going to Mike Cuthbert's talk, like Music 21 author, and he was talking about, how music is like very combinatorial. He says when he talks to a computer scientist and wants to talk about, how complex music is, he talks about, music is like combinatorial. Like there's so many combinations. So I was thinking about this when I was designing this model, thinking, we often think about modeling as next step prediction, as kind of we're all familiar with like language models. But a lot of times when we think about music, we sometimes think about the ending, and it's about how you approach that. So you're kind of working backwards. And as you're working, your workflow is also super, you're kind of just, you're putting down things at all places. So we realized, what if we had a model that could think about music or think about sequences as like all permutations? And that also allows you to interact with the music in these different ways. So for example, during generation time, because we know all the ways to put down things, we can actually do this rewriting process. And you can imagine, this can be a human AI rewriting process. And for the model itself, it also kind of improves the kinds of things it can explore. So what if we took that idea to an audio domain? Okay, so first I'll talk about kind of the creative kind of pursuit here. Wei Lu, who's a composer, multimedia artist at Harvard in the music creative practice and critical inquiry program. She's been hanging out with our group, and so she had this opportunity to write for an ensemble called Cat and Black. Like the cat was like, so she was even thinking, okay, what if we had an actual cat that the musicians would have to like interact with like in this performance? And then we had a researcher visit us, Hugo Garcia, who is the creator of VampNet, and he did a tutorial with us on the Unloop, which is built on VampNet, but a maximum MSP patch that allowed us to really, musicians to interact with it. So Wei Wu was really, really inspired by it and thought, okay, what if we create like a artificial digital cat with this model? So we actually have this interaction, kind of this co-creation setting where you have an artificial cat that's like in this cat ensemble. How is that going to affect like everyone's behavior and how, and what could happen? So Wei Lu felt like, like it's even if the model is kind of like learning from cats, it's trying to imitate cats, but there's so much that is unseen when you put this into a creative context with a stellar group of musicians that's going to engage with it and improvise with it. So a little intro on the VampNet. So in contrast to Coconut that works on the symbolic kind of the pixels of the notes, here Hugo is working on the pixels of audio tokens. So for example, you first take in a waveform and then you tokenize it, and then you have this pixel, kind of pixelated or pixel representation that you can do all kinds of things with. So for example, you can do this kind of masking that we saw earlier. And that affords you to do a lot of different kinds of interactions. So for example, you can do different kinds of prompting where you keep, so these tokens, one special thing about them is they can encode structure and kind of sound on these different coarse defined levels. So you can choose to, for example, keep some of the coarse level structure and then just rewrite the fine structure. So you can imagine for tone transfer and other kinds of curated applications, this is really interesting. So yeah, that could be some of the interactions. Others is, yeah, you could do rewriting in all kinds of periodical forms in different patches, and also even do, like, you can protect some of the beats to keep that kind of beat structure and then regenerate around it. So yeah, so Nitya and Weilu work together to really kind of adapt these systems for their use case. For example, like, yeah, training on cat sounds, and they went through many, many iterations of training and fine-tuning to really kind of find a balance between, like, yeah, we want the musicians to be able to relate, like, what they're playing to the rewriting, but at the same time, we want this to really sound like a cat, so it's really this fourth cat in the ensemble. And yeah, and it was, and Weilu thought about, okay, in the piece, we're gonna have this narrative, and for these different parts of, yeah, the narrative, we're gonna have different settings. So for example, initially, it's like, yeah, we don't know the cats yet, we can only see, like, the shadows of it. Sometimes it pops out, and then it disappears, and then it comes out again. So let's hear this first clip. So first, the musician does, like, a meow, and then later on, you'll hear the model doing that. And this model right now is working on these loops. So it's an 8-second loop. So you do have this kind of, like, offset that you kind of have to, like, yeah, guess, like, okay, is that a cat or not? So it's kind of trying to go for that. And the next scene is a cat fight. And then we was thinking, yeah, like, as the model, like, comes in, like, we need to make space for this fourth cat to come in. So in the next excerpts, there's more space, kind of opening up for the cats. For the artificial cat, and then you'll hear the cat kind of coming in all kinds of different ways. So yeah, whenever you hear a sound that's not like the cello, the bass, and the viola, that's the model generating. Yeah, so there's, like, cat meows is a signature, and then there's purrs, there's, like, scratchy sounds, and it's, yeah, all kinds of combinations. And the next scene is a cat dance. Yeah, so you hear it coming in. And another clip. So I hope you had fun with the cats. Is Weilu in the house? Okay, yeah. So please ask her more about it, and ask her for pointers how you can hear about the full piece. It's really, really imaginative, and I think it really kind of opened up my excitement about, like, yeah, how yeah, by working with musicians, yeah, the creative ways that we can envision is really much more infinite than we could imagine. Okay, so we're on to the last piece, which is an experiment we're doing. This is by Mason. He's at a film festival right now, so he's not been able to be here, but he will be here, and he will be presenting this work also at the end of the week, a demo after the Friday concert. So yeah, Mason's a singer-songwriter, and he's also thinking a lot about sound. Did a lot of signal processing at Karma with Julius. So he's really kind of trying to figure out audio, sound is something so hard to kind of, there's just, it's so hard to get a handle on. What are some ways that we might be able to capture more semantic variations on these different scales? What he's proposing is, what if we can do FFT on the spectrogram and get kind of this structure, but what if we did this on learned features? What if we did latent kind of FFTs and be able to, and then you're doing FFT on the learned features. And what he found is that, actually this is a way that you could capture a lot of the temporal variations, such as in the style, the arrangement, and the timbre. So a little bit walkthrough of how it works. So you basically kind of take a spectrogram and you do an autoencoder, so you're learning some features. And for the latent features, Mason can choose to filter different parts. So a little bit like the masked autoencoders you've seen, like VampNet, but using a different tokens and different representations. So there you would be able to do this kind of masking just like Coconut. And you can then ask a model to say condition on the low frequencies. Here it's like the low feature frequencies and generate, complete the top part, what kinds of variations could happen. So here I'm going to play you a couple examples. So this example is a guitar strum. So here what Mason is doing, he's keeping the highs. He's keeping the higher kind of frequencies. And what you're going to hear is it's keeping the guitar strum, but varying the styles. That was so it's going through these cycles. So this is completely unsupervised. The model is kind of learning these features, and we're doing FFT and on the features and figuring, and the musician can choose, which part do we want to keep? Next up, we have a little Christmas song, so I think it would be perfect if I give this talk again around December. And here we're keeping the lows. So the basic structure is retained, but the realization of it is being varied. That's it in English. The next one, we're kind of doing this gradual ablation. So we're going to start from removing the top, and then we're gradually going to remove more and more. So every time we remove something, that means the model has to kind of fill that in and generate that. So you can hear gradually the arrangement is being stripped out, and then the melody, and eventually the chords, and the whole piece is being rewritten. Mason has some caption there about what So you see the last one is like, yeah, when you go all the way down, then it's only the very global things are remaining, the style and the key. Yeah, so that is the series of work I wanted to share with you. And yeah, I feel like there was this kind of, we went from maybe thinking about, yeah, kind of this three-hand piano, like, yeah, thinking about an extension to yourself, to thinking about, yeah, what if you had a new member in the band that like had, yeah, very different kind of sensibilities? How would that kind of modulate the dynamics of the interaction between the ensemble? So for me, I think and this community is like, I'm really excited to see everyone's piece on the concert, and see what are all the range of things that we're imagining, and I think that's all kind of really, really relevant to kind of like bounce ideas on. And yeah, this is the end of my talk, and so some of you might know already, it's really exciting, we're starting a new music tech graduate program at MIT. So here it's Iran Igozi on my side, and he's organizing this really amazing concert on Friday. I am also starting a new lab in CSAIL. It's joint between Music, Theater, Arts, and also EECS. And our new lab name is Human AI Resonance. And yeah, the acronym is HiRes, and it happens to be pronounced HiRes. So we were really happy when we landed on that. This is my amazing group of students and collaborators who, yeah, there's half of them are away for internships, so half of them are here, so it's really great. And yeah, please come join us on Friday. It's a really amazing lineup, and I'm really excited to see all the different ways technology can be really empowering a range of creative expression. So thank you very much.
Thank you. Thank you, Anna. It was amazing, as expected. We have time for questions. So, yes, I see one already. Maybe down there was the quickest one.
Hello, thank you. I'm not used to ask questions after a keynote, but I'm taking the, chance. Thank you very much for this very nice journey. So my question is about your perspectives. So it seems your work is collided by so much valuable student works and some different disciplines, like you mentioned prosthetics, and my question is about your either like a hidden ultimate goal behind that you would like to pursue, and if yes, like in 20 years, something you would like to achieve in the technology music, and is this goal the same as for your first ICMC, or did it change already 10 years or 15 years after? Thank you.
Yeah, thank you so much for that question. Yeah. I think I'm so excited to be back at ICMC because I feel like in some ways I'm kind of, this will enable me to return from my initial kind of, spark of like why I wanted to, be in this field. And so when I was in college, I actually majored in music composition. And I was in Elaine True's lab. And Elaine brought in so many amazing researchers around the world. And one of them is Gerard Asea. Gerard, are you? Yeah, so Gerard's there, yeah. So I just remember being really blown away by Gerard's work. And later on, like every couple of years, I see Gerard's work, and I remember, thinking like, oh, I'm like in the wrong place. I need to be like at ICMC. And so I feel like, finally, like I feel like now I just feel really, really lucky. I feel like I'm in a place where I can start exploring a lot of those early ideas. And I also feel really lucky. This next year I'm doing the Radcliffe Fellowship at Harvard, so I'm hoping that will give me kind of more space to do creative work. So maybe all of you will hold me accountable for for doing something more creative.
So it seems like the way forward for real-time co-creativity with AI is definitely reinforcement learning. Would you say that that's the key there? It's very interesting seeing that, what you're doing with it.
Yeah. I think there's many ways, and I think it's always going to be a hybrid, and each kind of, there's so many different ways to kind of think about it, and reinforcement learning is one way. Some of the things it allows us to do is we're not just working with like existing kind of data sets anymore, but we can actually kind of fantasize and kind of get feedback on that. I think being able to, reinforcement learning does require like some kind of reward function, which is super hard. So I think that's a space that takes kind of a lot of creative thinking. And I think what I'm most excited about reinforcement learning is more about, because I think it shifts the focus from kind of, I guess we're modeling music here, so I'll say music. It shifts us from the focus of music itself to the interaction between agents. So for example, we're thinking a lot about multi-agent reinforcement learning with that Yusung Wu. I didn't manage to give a shout out to Yusung Wu earlier, so he. Thank you all. So he's really pioneering the work in reinforcement learning, and now he's working very hard on thinking about multi-agent reinforcement learning. So we really think about this interaction.
Hi, wonderful talk, wonderful presentation. Thanks. You've shown a lot of models, a lot of approaches, and I remember when Music Transformer came out, and I was playing with it, and now it's still a thing we talk about, but the Google notebook doesn't work anymore, for example, right? And like the way forward seems very exciting. You're showing a lot of things, but I'm wondering if you have any opinion on the past. What do we do with all of these models, like Coconut, Music Transformer, all the models that pop up at conferences? What do we do with them? Are they supposed to be not necessarily forgotten, but put in an archive, or are there ways to still exploit them, or are we just moving forward? That's a super good question. One of my friends, Bob Sturm, he was working with Music Transformer a lot, and when the notebook stopped working, he was really sad, and he said, there needs to be a museum for these older models. And maybe I'll turn to like ICMC, because a lot of the max patches, early maybe, that's not maybe in pure data, there's definitely, I think it's a whole team needed to be able to do this kind of archival and be able to kind of revive some of these, I think that's a really interesting space to kind of think about, what is, like with the synthesizers, if you have the instrument, then hopefully you have it for a while. But now, like with these, kind of software-based, it's constantly changing, and we're constantly trying to keep up. So maybe we can brainstorm some possibilities here.
Something here, let me add. I know that at IRCAM, Miller Paquette is working on something like that, on a way to preserve not just objects, but also full patches that are used for specific pieces. And Miriam Ackerman, who's one of the ICMA board members, is running it's not a conference, it's more of a, like a biannual meeting on preserving electronic music technologies and output. So that's a nice conversation to have with
Do you mention Miriam?
Yeah.
Okay, she and I actually overlapped in Gerard's group when we were visiting one summer. So all the connections are coming back.
She could be the right person to
Yeah,
actually
yeah,
have a
I
conversation about this.
absolutely love that. Yeah.
Oh, okay, sorry.
Hi, thank you so much for the talk. A lot of really exciting work. I remember one project you talked about in particular. You said that they were able to grab tokens from the audio. So I'm wondering, were these tokens obtained in real time, or was this more of a post process? And then my other question is, what were the types of tokens in particular, if you remember?
Is this the VampNet work that you're thinking about, Hugo?
Yeah, I think there was a slide you showed. There was a bunch of different layers. It seemed
Yeah, like very colorful.
Yeah.
So that interaction or that setup is kind of a looper setup. So it's not like super real time. But yeah, we're definitely interested in kind of getting it. There's a lot of ongoing work because these kinds of architectures are also used in speech, and people are doing kind of like real-time dialogues. So that area is very, very active. In terms of the tokens, it's this, kind of people are always trying to figure out how to tokenize very complex objects because it seems once it's tokens, it's easier to model. But audio is so complex. There's so many levels of structure. So these kinds of tokenizations, try to really get at the different levels of structure. Yeah, in particular, this one is like a residual vector quantization. So you go through this encoding multiple times, every time like capturing the residuals and encoding. Yeah, so getting finer and finer fidelity.
Hi, thank you so much for this incredible talk, and I'm so excited to see all of the advancements that are happening in the music and theater arts section. One question I had, and the person who brought up the point about the notebook not working anymore. I feel you on our archival needs for that. One of the questions I have, particularly as an MIT alum, is that ethics and accountability was completely left out of the vast majority of our education. Everything was so focused on solving technical problems. And so I'm really interested to hear more about how, particularly within music and theater arts, that focus is being centered and not treated necessarily as an auxiliary consideration, right? But how do we embed those types of literacies and fluencies pedagogically and experimentally, research-wise, into what we do?
Yeah, that's a super good question. MIT definitely has an effort called kind of society, ethics, and responsibility. So there are new courses being created that kind of bring students through a series of case studies to kind of be able to see, what are the implications in the larger societal context. So I think there's so many issues and kind of at stake. So for me, like I think working very closely with musicians and listening to the community and constantly being in this feedback loop is very important. Everyone has like coming from a different perspective, so being able to listen to these different perspectives I think is very important. Oftentimes like technology is a little bit developed in isolation. Like we have engineers and then we have engineers design the tools, and then at some point, somebody starts using it, and then we realize, there are these challenges. So my hope is, being in the music department, we're able to do that co-design more in a more fluid way. I mean, it's really messy, but really engaging in a tight feedback loop, I think, is very essential.
We have time for other questions, maybe a couple of questions. Anyone? Yes.
Thank you for a great talk. And I'll just have a little bit simple question about the reinforcement learning in the music domain, because that was really interesting for me, because normally when we train the model to generate the music AI, then we simply have the training data set and trying to compare the kind of like a similarity between the existing music and the generated music. So trying to lower the loss, that might be one of the main factors that we train the model. But when we're using the reinforcement learning, there should be like reward system. But I don't know. I just wonder, how can we like implement that reward system for creating the music? So could you just explain about it? a little bit more deeply about it.
Totally, totally. Yeah, I think that's one of the core kind of questions we're exploring. Yeah, so actually, like after this conference, Yusong's here for a couple of weeks, and our plan is actually to do a hackathon to think about all the different ways we could learn from human feedback. So yeah, with a lot of these kind of large language models, we realize reinforcement learning with human feedback is very, very crucial to get the kinds of behaviors that we want. And in music in particular, it's every piece is different. Every piece has its own kind of creative priorities that we would want to kind of design that feedback signal differently. So what are some ways we can have richer feedback that's not just like, oh, this is better than that, but it's kind of richer, like kind of embedded in this interaction that we have.
Second question. Yeah, we do.
So it's a combination about preservation and reinforcement learning. As in the human brain, there are those tremendous reconfiguration. For instance, at 5 years old, the brain is completely, but still it's the same brain, right? The same machinery. So could we think about like a global machine learning scheme that would avoid to drop off existing models, but rather kind of like make them evolve, integrate them to finally end up at like really like learning on a long-term AI companion. I think I'm a composer, so I'm thinking of, I would dream of like some kind of tool that's like remain in time, and where I could ask like 20 years after, you remember what we composed together, could you generate something like this specific composition that we addressed together at the time? That's kind of a dream, huh?
Yeah, I think a lot of times, like people are talking about kind of AI assistants, and in some ways, that's what you would kind of expect and hope they would have. Yeah, that richer context of interaction. Definitely in the field of robotics in particular, people have been thinking about lifelong learning, and really thinking about this you're working together for long periods of time, how that would evolve the way you interact. I think there's a lot of adjacent disciplines to us that are thinking about a lot of these questions. I think it's very interesting to have exchanges with across.
Thank you so much. Let's give it a round of applause again. Thank you, Anna. Thank you, everyone. The next event is concert number 4 at Fenway Center, Northeastern. It's a 5 to 7 minute walk from here. There's also a coffee break in the meantime so that you can slowly get there and enjoy the music. See you later.